Okay, in the second part, I'm going to continue to talk about the advanced use in the MongoDB. So here, what I'm going to talk about is scaling strategy in MongoDB, basically. So before that, I want to talk about why we need a scaling strategy. So the first of is this. So last time we talked about indexing, and usually inside of a computer system, what's going to happen is this. In MongoDB, you will try to run some query and you will try to do something based on the data you have. And when you run query, what's happening is that the computer system will retrieve the collection and index together, which is an index embedded on that collection together. So into your memory, which is RAM inside your computer. So when you have a RAM, the current working set, which is a collection, and the index, which is attached on your collection, will be loaded into the RAM system like this. So if you have a not too big collection, it should be fine. It will fit into the RAM. Even though it's a little bit bigger, it will fit into the RAM. However, the problem is that when you have a big data, when you have a lot of documents inside the collection, it may not entirely fit in your RAM, something like this. So the size of collection might be bigger than the RAM size in your PC. So that may happen. If that happens, what's happening in the computer system is this. The current working parts, so some of the parts in the collection will be loaded into RAM. However, the remaining parts of the collection will be still in the hard disk drive. And whenever we need that part, the swapping will happen. So basically, the necessary data will be loaded back into the RAM, and the currently working parts will be saved back into the hard disk drive. So that's what we call swap in the computer system. The thing is this: if there are more swaps, basically the performance will decrease. So that's the main thing. So how to overcome this problem? The first way is vertical scaling. So we can scale up the system. So basically, we can add more power into the PC or server. So if the RAM space is not enough, we put more RAM. And the CPU is not that fast, we put a stronger CPU. Basically, we upgrade the computer, so we make a supercomputer as a server. So that's the first approach. And the second approach is this. We can simply add more machine. So this is what many big data systems do because the first approach, the scaling up, it has a limitation. You can upgrade your PC, you can upgrade your server, but there's a limitation. So at certain point, you cannot upgrade more, or it costs too much to upgrade something. So that may happen. So usually what we do in the big data system is horizontal scaling. Basically, we're scaling out, which means that we simply add more small machines into the system, and we add and connect more servers, and we simply make a distributed system or network in the database system. So this is what we call a sharding in MongoDB. So it's something like this. So we have this big data. Basically, we have a huge document inside the collection. So we divide them into A part, B part, C part. So we save A, B, C in different server. Then the operation that can happen in A, they can happen there, and we can do it separately. So it can be still fast, even though we have a huge number of documents inside the collection. Then the question is this: how we have to divide it, and how did we assign a certain document to be saved in A, and how should we determine a certain document to be saved in B? So the question is this: what goes into A and what goes into B? So we have to determine that. So when we assign this basically, so which part of a collection should be saved in which server, we determine based on the shard key. So as a developer, as a database manager, you have to determine which field will be used as a shard key, and based on the value of that field, it will be determined which document is saved on which server. So it's something like this. You have a big collection like this. You have 1 terabyte of a collection, 1 terabyte of documents, and it will be saved into 4 different servers. So each server will contain 256 gigabytes of document. And based on the shard key, you will determine which one is saved in which server. So when you have to use sharding, there are two possible scenarios. The first scenario is that you don't have enough disk space to store all the data. So you have too much data. The size of data is too big. Size of collection is too big. Then you have to shard because you cannot save everything in one server. Second scenario is this. You want to handle query better. So you want to increase the number of operations your server can do. Then you have to also use sharding to increase the performance. Basically, to increase the processing speed, you can also utilize sharding. So basically, when to use sharding, the first one is because of this, data cannot fit into one server, then we have to shard. We save it into different server. And also, this part. The part of data, the C part, will be accessed a lot from the user. Then you make a replication like this, right? By storing the part of C into multiple server. In that case, you also do sharding because you want to increase the processing speed. So in these two cases, in these two scenarios, you may use sharding. So I'm going to show how the companies utilize sharding actually in the real world here, very briefly. So there's this online service called the FourSquare. Actually, I'm not sure whether this is still popular, but back then, a few years ago, this was a popular service in the US. So what this service is doing is very simple. So you go to a certain restaurant, you go to a certain like a famous place or park, you want to share your location with your friend. Then you simply go to this FourSquare app and you just check in. And then this app will record that you are there at this moment. Then this information is shared with your friend. So your friend will know that you are in a restaurant or in a park. And if they are nearby, and if they want to meet you, they will call you or something like that. So that's the FourSquare online service, which was popular back then. And this online service at that time had 50 million users registered on their server, and they had 6 billion check-in information. And also, there were 55 million points of interest, points of place, basically, people can check in. And there were about 1.7 million merchants who are using their platform for the marketing purpose. So for this FourSquare, they received about 300,000 operations every second. So a lot of people were using it very actively. And they were utilizing MongoDB to store all this information. And it says that they had about 5.5 billion documents. So they had a lot of user documents in their user document and check-in information stored in their MongoDB server. So 5.5 billion documents. So the size of the document is size of collection will be huge. So they had to utilize sharding because all these data cannot fit in one server, and they also have to handle user requests quite fast. So they utilize the sharding approach. So basically, by using MongoDB, what they did is that they made 11 MongoDB clusters. Basically, 11 MongoDB servers they made it, and each cluster had multiple shards. So in the largest cluster, they had 15 shards to store check-in information. And when they are utilizing sharding, they used a user ID as a key field to shard, basically. So based on the user ID information, the MongoDB determined which document is saved on which server. So basically, the check-in documents of the same user are stored in the same server because they use user ID for sharding. So what it means is this. If they don't use user ID for sharding, and if they use another field for sharding, then this problem may happen. So let's say that this document contains check-in history. Then user age check-in history will be saved in many different documents. And if you don't use the user ID for the sharding key, it's possible some of user age check-in information might be saved here on shard B, and another check-in information of this user might be shared in the shard D. That's possible. However, if you use user ID as the shard key based on user ID, if the user ID is the same, it will be saved in the same server. So all of user age check-in information will be saved in the one server because you determine user ID as a shard key. So another user B's check-in information will be saved on the same server like this. So if you do that, basically they can provide a fast read and write performance. So how to do that is this. So let's just say that someone accesses the user age profile page. Then if someone goes to user age profile, we want to list all of his history of check-in information. So basically we can list history of where this user age visited. So because if we shard based on user ID, all user age information will be saved in this one server. So we can send this request to this server, and this server will send the results back to him, back to the application. Then we can show everything. However, user age information is saved in a different place. We have to check this server, and we have to look at all the documents, and we have to check this server, and we have to look at all the documents, and then we have to display information. So it will be more slower because we have to check more documents in two different servers. So in this case, sharding based on user ID will allow it to check only documents stored in one server. We have to only check 256 gigabytes of documents, then we will know all the history of user ID. So in that way, the FourSquare, by using user ID as a shard key, they can increase the performance because all the user ID information is stored in one server physically. So this is how MongoDB will handle the user requests and send the query requests into different servers. So this is a basic structure. So first of all, there's application. So application is basically something like a website or online service or mobile application you provide. And user will use the application to send a request. And if application receives a request and if it directs to the MongoDB, the driver will handle all interaction between database and the application. So basically, driver is something like a connector in relational database. So when you want to access MySQL from third-party application, you have to install an appropriate connector. So driver is something like that. And then driver will send the query request to the MongoDB. Then in MongoDB, there is something called the query router. So query router will receive request from user and it will redirect the request to the different server based on the shard key basically. So yeah, you may have a multiple shards like this. Basically, each shard you can consider it as each server, and each server there can be primary collection, secondary collection like this. So primary collection is something like main information. So let's say that earlier example in FourSquare, they use the user ID as a shard key. So user age information is here, user B's information is here, user C's information here, something like that. And if user A is a popular person, so like a celebrity, then a lot of people will try to look at user age information. Then you can make a copy in different server like this, so that you can handle multiple requests at the same time. So that's the basic concept here. So these are some of the examples here. So let's think about like a Twitter example. And let's think about how this actually works, this system. So in Twitter, there are multiple users. So let's say that Obama's information, Obama's tweets are saved in this server here in the primary on the shard 1. So if Obama writes a new tweet, that request will be sent to the driver, and driver will send it to the query router, and query router will see where Obama's information is stored. So Obama's information is stored in this primary part on the shard 1. So it sends that request here, and Obama's new tweet will be added into primary. And again, Obama is a famous person, like a celebrity now. So many people will try to look at Obama's tweet. Then we can make a copy of Obama's information in other server. So in that case, we can make a replication here on the secondary parts of shard 2, and we can also make a replication on the secondary part of server 3. So basically, these two are copy of this primary. So we make a copy into different server. And in the future, users are asking to read tweets from Obama. Let's say that there are 3 users, user 1, 2, 3. They all want to read tweets from Obama. Then user 1's request can be sent here, server 1. And user 2's request can be sent to server 2. User 3's request can be sent to server 3, so that we can process the 3 people's requests at the same time, because each of shard is a different server. So different computer will process 3 requests at the same time. So that's possible. So that's briefly how the MongoDB architecture is able to utilize sharding to process multiple requests. And sometimes for a global company, for an international company, when they provide an online service in multiple locations, multiple countries, they sometimes utilize a geo-location sharding. So based on the location of the user, they use that location for the sharding. What it means is something like this. So shard 1 can be used as a server storing US information, and shard 2 can be used to store information about Hong Kong, shard 3 about Korea, shard 4 for like Germany or something like that. So this is quite common in the international company. So earlier I mentioned that these days the data storage is quite cheap. So company utilize multiple data center across the world. So some international company will have their server in the US and also in Europe and also in Asia, something like that. So in that case, we can utilize those servers located in each country to provide the service for the users in that country. Then it can be faster because the request will be physically sent to the server inside the same country and handled inside the server in the same country. So in case of Netflix, if we think about Netflix, they can utilize this kind of a framework basically. So Shard 1 is for the US movie for US user. Shard 2 is for Hong Kong movie for Hong Kong user. Shard 3 will be Korean user. Shard 4 will be Germany users in Germany or Europe, something like that. In the case, in the primary server, we have to store the movies which is accessed mostly by the users in that country. So for US users, they will watch a lot of US movies. So we store US movies here on the primary. For Hong Kong people, they watch a lot of Hong Kong movies, and we can put the Hong Kong movies here. For Korean people, they watch a lot of Korean movies, and we can put Korean movies here on the primary server for the Korean shard, something like that. And also depending on the behavior and use of applications from the users in each country, we may have additional information. So when we look at the Hong Kong users, let's say that we found that they mostly watch Hong Kong movie. However, they also watch the Korean movie a lot, and they don't watch the German movie that much. So let's say that we found that. Then what we can do is that whenever Hong Kong people are watching Korean movie, currently they have to access Shard 3, which is located in Korea. However, then because of the physical distance of the server, the request will take longer. So we simply copy this part into here in the secondary. So we also save Korean movies here on the secondary part in the Shard 1 basically. Oh, not here, actually here. on the Shard 2 for the Hong Kong server. Then for Hong Kong people, when they watch Korean movie, we can simply send that request into the server inside Hong Kong, because that information, Korean movie information, is also copied here, so that the request can be handled fast inside the country. And for the US user, let's say they mostly watch US movie, but some watch Korean TV series, and they rarely watch Hong Kong movie. Let's say that. So let's say that this is what we found. Then we can also save Korean movies here as a secondary, so that when US people watch Korean movie, that request can be simply handled inside the server located in the US. So basically, that's the concept of geolocation sharding, and this is what many international companies providing global service are utilized these days. So the next question is this, the replication concept in the MongoDB. So when we have like a primary part in the shard and secondary part in a different shard, how we manage that they are having the same data. So we use this replication concept basically. So we have a primary data set in the shard, and we have a secondary data set, which is a copy of a primary data set in different shards. Then inside the MongoDB, they will keep sending a signal regularly. So every few seconds, they will send a signal. So they check each other to see whether there was any update. So if there is any update in one of these data set, it will be synced. So if there is an update here, the update will be reflected here on primary and also on secondary, like this. So that's what MongoDB is doing, so you don't need to worry about it. And what happens if one server dies? So let's say that on the one server, which has a primary, there was a problem. So we cannot access this data set anymore. Then only two secondary are left. Then one of the secondary becomes primary, and they keep communicate by using the heartbeat. And yeah, and even though one server fails, they can keep providing service because of the secondary data set is still alive in this case. So this is how you can create the replication in MongoDB. So you don't need to know like this exact process, but I just put it here for your reference. So in the future, if you want to utilize it, you can try this basically. So this is something you can actually test. So in your one server, if you want to test the primary and replication concept, you can basically try this code. The first code here is basically making directory. So mkdir is command you can use in Windows or Linux or even in the Mac system, which is about making directory. So here I make 3 directory here. Basically, each directory is to save the data set on each part. So this is rs0, rs0-1, rs0-2. So this will be primary. These two will be used as a secondary. So I'm simply making a space to store data first. So currently I'm making 3 directories because I'm testing it in one server. But if you have a multiple server, in each server you will have a different directory. And then here using these 3 codes, I start the MongoDB service. So basically, this is server 1, which is using port number 27017. This is server 2, which is using port number 27018. And the last one will be containing dataset, which is using port number 27019. So basically, the main concept is this. You have 3 servers, and each server contains different data, each server will start with a different port number in this case, basically. And then you use this code to simply connect one of the server So in this case, I connected to port 27017. Basically, I'm connecting to the first MongoDB instance, basically. So after you connect to the first server, you can try this code. So rsconf is basically I'm putting some configuration for the replication set. So basically I'm making ID, and here I put the host, which is port with 27017. So basically the first server instance I opened will be used as a main server, which is a primary data set. So that's what I'm setting here. And if I use rs.initiate function in the MongoDB with this configuration, then the first server with the port 27017 will be used as primary data set in MongoDB. And then if you use rs.add function, and if you add 27018 and 27019, these two servers with two different port number will be secondary data set. So the data set on the first server, which is a primary data set, will be copied into these two servers. So that's what this means. So that's basically how you can set replication secondary data set in MongoDB in different server. So simply you have to put IP address here and the port number here. Then you can add another server into the primary data set to make that as a secondary data set. So again, I showed this because it's one of the functions you can utilize in the MongoDB. You don't need to know about this for the final test, but I want to introduce this so that you have at least you have an understanding about this part basically. So the more information is in this document. So in the future, when you try to set up this with a multiple server, depending on the system, there are slight difference. So and there is slight different things you may encounter. So there are more information will be on this document here, so you can check that. So and after you set all these things, if you have to deploy your MongoDB, basically, if you want to make your MongoDB server available, you have to do the deployment. So you can check this document here again for that part. So I skip this in this class. So basically, that's basically how you can set up the application and utilize it in MongoDB. So the last thing is administration in MongoDB. So currently, when you use Robustity to connect your MongoDB server, we didn't type any user account. We didn't type any username or password information. We simply connected and we worked on it because we are utilizing the developer system. But later, if you deploy your MongoDB server available to other users, then it's always good to make a user account inside MongoDB. So how to make a user account? You can do it simply through these steps, very simply on the Robustity. So you can just go to the local database, and on the system folder, there is an admin database, and there is a user. There is a user folder. So you can right click on there, and you can click add user. Then you can add a user, and you can make an admin user account inside of MongoDB. And also, if you want to make a user account for each specific database, you can also do that under each specific database you want to make a user using the same steps. And when you add a user, there are multiple options here, as you see. Yeah, there are multiple options here. So whenever you add a user, you can determine the username and the password here, and you can also determine the role of user. So if you choose this one, database admin, any database, it means that the user, this user is able to access and change any database in this server. So that will be for admin account, for the data administrator. if you want a user to only read your database, you can check this. Or also, if you want to give a read write option, you can also check this. So depending on what you want and what kind of roles you want to give to the user, you can check different options here.